two words in this topic, and basically the chapter also have two parts. Permutation. So permutation is basically when we have to arrange something. So this is actually arrangement. Okay, so which means that if we have some object and we have to see how many possible orders of arrangements are there. So here the order matters. For example, if we have three letters A, B, C. So how many arrangements are possible in this case? That we can check. If we fix A and we shuffle the other two objects. So one is BC and fixing A, the other is CB. So two options. Then if we fix B in the beginning and then AC or CA. And if we fix C in the beginning, then A with B and B with A. So these are three different objects. So three different means distinct. Three distinct letters or objects. So how many arrangements are possible? Total number of arrangements are total number of arrangements six, right? 6 arrangements. There is a rule which will be used here. So every time we are not to do like this. This is only I gave you an example. So like if there are 10 objects, so it is not possible for us to find all the possible arrangements. We can find the number of arrangements by using a formula. But if we are to arrange those 10 objects, it will take almost a lot of time, a lot of efforts, paperwork. So for the permutation, which is arrangement, we can use a formula which is NPR. NPR. It's a mathematical function. So N means how many items we need to arrange, how many distinct items we need to arrange. So here in this case, these are 3. Okay, so I will write here N stands for distinct objects.
Sir, this formula, it's on our calculators too, right?
Yes, it is also available in the, it's a function, mathematical function. Distinct items given. Okay, and R will be the items to be arranged. So see, in this example, we have 3 given, so it means N is equal to 3. And how many we have to arrange out of these 3? We have to arrange all of them. So it means R is also equal to 3. So this means that 3 permutation 3. E stands for permutation. So 3 permutation 3, if you use the calculator, so you will get it 6. Okay. Now, if every time we will not have the calculator with us, if it is multiplication or division, something like that, so we can do without calculator. Now, how can we do 3p3 without calculator? So that's why we have to learn that what actually NPR means. Okay, this is the part of pure maths which we are using in applied math statistics here. So NPR means N objects are permutated at R different locations. So mathematically this is equal to N factorial divided by N minus R factorial. So So in grade 11, you are not familiar about the factorial. Factorial, this symbol is a sign of exclamation. I will write here where n factorial is, we write the number n into a number smaller than that, which is n minus 1, and a number smaller than that, that will be n minus 2, and we keep on decreasing 1 from these numbers until we reach to 1, like 3, then times 2, then times 1. For example, if we have 4 factorial, 4 factorial means 4 times 3 times 2 times 1. So 24. So 4 factorial is 24. Okay. So if we use, there is no factorial of the negative numbers. Negative, because negative number will never stop. And there is, just a minute. Okay, there is, I was talking that there is no factorial of the negative numbers, because let's say if we want to take the factorial of -2, so we have to subtract 1 in each stage. It will be -2 into -3 into -4. It will keep on going, it will never end. So it's a never ending chain. Okay. So it means that negative number factorial is not possible. So factorial of negative number negative integers is undefined. Only we'll have the factorial of the positive numbers and 0. So by definition, we are saying that factorial of 0 is 1. So it is defined. So by definition, 0 factorial will be equal to 1. And 1 factorial is obviously 1. 2 factorial will be 2 times 1. 3 factorial will be 3 times 2 times 1. So we keep on decreasing until we reach to 1. Okay, so this is about the factorials. We will do more detail of the study of factorials later, because now we are doing the topic permutations and combinations. So permutation is the arrangement, right? I'm dividing this. Permutation is the arrangement, and the formula to use, find the total number of permutations or the total number of arrangements when n objects are given and r of them are to be arranged. So NPR will be used there, and NPR is n factorial over n minus r factorial. So now we will apply this on this example. A, B, C, 3 distinct objects, n is 3, r is 3, so 3p3 is equal to 6. Now see how we got 6 without calculator. If we use this formula, so we are having 3p3, which is equal to 3 factorial over 3 minus 3 factorial. So which means it will be 3 factorial over 0 factorial. And 3 factorial is 3 times 2 times 1 divided by 1. See, this is equal to 6. So manually, if you have to do, you will do it in this way. Okay, but calculator is allowed, so you can take care of the calculator here. So is it clear to all of you? If anyone having doubts, you can ask.
No, sir, it's clear.
It's clear. Now additional information here, that whenever we have n objects given to us, and all the n objects we are shuffling, which means we have to arrange. So instead of using this formula, which is NPR, we can apply a short formula, which will be n factorial. Because here we have seen we are arranging 3 items. So why we are not doing 3 factorial only? Because in this case, every time according to the formula n minus r, 3 minus 3 will become 0. So this is r n minus n will be 0 factorial. So denominator will always be 1 in this case. So it means we can say that this is also equivalent to 3 factorial instead of using 3p3. Okay, so is it clear? Now see that I will write here the fact. In orange color I am writing the tool which we are using in permutation. So NPN means that n factorial because they have the same value. Okay. So this is one formula and the other one is this, and it is used in finding the number of arrangements. And the condition is that all the n items are distinct. So distinct items are taken. If some items are repeated, so that kind of situation we will do later. Okay. First we will get a perfect training of distinct items. So basically we have only one formula, which is NPR or n factorial only, but different type of situation will be asked to us. Like for example, 3 books we have and we have to put them in a shelf. So in how many ways we can arrange them? So 3 books. Book 1, book 2, book 3, book 4. Book 1, book 2, sorry, 3 books, book 2 and book 3. So these are 3 items, so n is equal to 3. All the 3 are different, so it means the answer will be 3 factorial. So these are the number of ways of arranging 3 books. Okay. So the question may also be asked in this way, that I will write here as an example. So there are 5 students and there are 3 chairs. Obviously students will be different. Whenever we have living items, they are always distinct. And 3 chairs. Chairs may be identical or same, it doesn't matter. So the question is that in how many ways these 5 students, 3 of these 5 students can sit in these 3 chairs. So find the number of possible ways in which these 5 students can sit. 5 students logically is not correct, so I will change the statement. In which 3 of these five students can sit. Okay, so any one of you can tell that what will be n and what will be r? Yes.
And R is 3.
Yes. So NPR we are using because we are to arrange. It is arrangement. Here order matters. So So it is arrangement. So NPR. So here n is equal to 5. Total students available are 5. And how many of them will sit in these 3 chairs? Obviously 3 of them will sit. So R will be equal to 3. So then it will be 5p3. So then this will be 5 factorial over 5 minus 3 factorial. So it will be 5 times 4 times 3 times 2 times 1. And this will be 2 factorial, which means 2 times 1. So 2 times 1 is cancelled, 5 times 4 times 3. This is the, if we are not using calculator. 5 4s are 20, 20 times 3 is 60. So there are 60 different ways in which 3 of these 5 students can sit on these chairs. See, there are only few items, but the number of ways are quite large. Okay. So if you want to think that what is the inside story of this, that how these are 60. So basically, if we say that we have the students A, B, C, D, and E. These are the 5 students. So how can they sit on 3 chairs? So let's say first A, B, C, these 3 students are sitting in the chairs. So how many ways these 3 can sit? This can sit in 6 different ways. We already have done this in the first example. Like A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, D, A. These 6 ways. So whenever you have 3 distinct objects, so the number of arrangements will always be 6, 3 factorial ways. Or it will be A, B with D. This is another set of 3 students. Or there will be another set of 3 students, A, B, E. Or there will be B, C with D, like these 2 with the next. See, in this way, there are many options, B, C with E. Each one will have 6 ways for this, 6 ways for this, 6 ways for this, right? So only since we started the lesson, and that's why we are doing in detail. Otherwise, this working we don't need to do. Only to make the concept strong about this, we are doing this. What are the other possible ways? BC, BAD. Remember, BAD will be in the same, because when you shuffle them in these 6 ways, it's counted. First I took AB with C, then AB with D, then AB with E. Then BC with D and BC with E. Okay, so then now I will take BC, BD or CD, the 2 consecutive. CD, yes, anyone else can tell, CD with E, right?
Yeah.
And then I will take alternate, like B, AC, AC with D and
AC.
AE. Okay, and then I will take AD with E and then BD with E. See, BD with E we have not done before. Alternate B. Before I took 2 consecutive with any of the other. Then after that I took alternate, like AC with E and then BAD with E and now BD with E. Is there any other option? I think no, because 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 6. Now these are the 10 different ways to select 3 of the students from these 5 students, and then each of the 3 will sit in 6 different ways. These also will sit in 6 different ways. I will just copy this down to save the time. Okay, so overall if you see 10 times 6 is 60. So these are the 60 different ways. See, in this way, even there are only 5 students, so we are getting 6 different ways, and manually if we are doing, so it takes a lot of time. If there are, let's say, a class of 30 students, and we have to choose 3 of them to sit in 3 chairs, so that will take a lot of time if you do in this way. But using the permutation formula, it will take only a few seconds. So there is a class of 30 students. So example 2, 30 students, and to sit on or in 5 chairs. Okay, 5 chairs. The situation is clear. Obviously, all the 30 will not sit. 5 of the students will sit in these 5 chairs. So n will be equal to 30 and r will be equal to 5. So 30p5. Now using the calculator, you can also find it directly. If you use the calculator, then it is on the shift, either multiplication or division button in most of the calculators. So I will see my calculator. Yes, so it is at multiplication. NPR is at multiplication and NCR is at the division. So first we write the value of n, 30, then shift multiplication sign, you will get P on the screen, and then 5, and then press equal. So you are getting a very big number. Okay.
17,100,720.
Yes, yes. So it will be easy if we speak digit wise, 171,00720, and then comma here, 17 million, more than 17 million possibilities are there. Just 30 students are making these possibilities.